The James Webb Space Telescope has delivered the clearest image of Proxima B to date, offering remarkable insights into this potentially habitable exoplanet. It invites us on a cosmic journey to uncover the secrets of Proxima B and to explore whether this mysterious world could be our next Earth. Orbiting within the habitable zone of its star, Proxima Centauri, this distant planet isn't just another rocky body in space. It's real and it's intriguing. Located just 4.2 light-years away, Proxima B is shrouded in mystery and possibility. Could it harbor oceans? Could life be thriving on its surface? But wait, there's more to the story. Proxima B isn't alone in its system. It shares its star with at least one known companion, Proxima Centauri c. And who knows? There could be more waiting to be discovered in this intriguing system. What secrets still lie hidden in the glow of this nearby red dwarf? Proxima Centauri emits roughly the same amount of energy to Proxima B as our Sun does to Earth. That similarity sparks hope. Might this planet support liquid water and potentially life? As we reach beyond our solar system, we discover a universe teeming with exoplanets, worlds that orbit stars other than our own. With an estimated 200 billion stars in the galaxy, the possibilities for life-bearing planets are nearly limitless. Some exoplanets even drift through space without a star, like cosmic nomads. Among this vast population, Proxima B stands out. It completes an orb around its star in just 112 Earth days and lies much closer to Proxima Centauri than Earth does to the Sun. Due to this proximity, it's likely tidally locked. One side of the planet always faces its star in perpetual daylight, while the other remains in eternal darkness. Now let's look at the star itself, Proxima Centauri, the sun around which Proxima B orbits. It's part of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri B, also known as Rigil Cantoris. These two stars form a binary system visible as a single bright point in the constellation Centaurus, and together they're the third brightest star in our night sky, with peak luminosity just under 2.7. Proxima Centauri, also referred to as Alpha Centauri c, is a red dwarf, or M-type, star located 0.21 light-years from its two sibling stars. That's about 4 times the distance between Earth and the Sun. It's the closest known star to us, hence its name Proxima, Latin for nearest, and was discovered in 1915 by Scottish astronomer Robert Thorburn Ayton Innes. Despite its proximity, Proxima Centauri is too dim to see with the naked eye, with an apparent magnitude of 11.13, far fainter than the human visual limit of 6.5. Still, don't underestimate this tiny star. Red dwarfs like Proxima Centauri are incredibly efficient, burning fuel slowly and living for trillions of years thanks to their convective interiors. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, its potential to support life is controversial. As a flare star, Proxima Centauri frequently unleashes intense solar flares. Its habitable zone lies much closer than that of the Sun, estimated to range between 0.023 and 0.054 Australian dollars. But this closeness comes at a cost. Proxima B is regularly bombarded by powerful ultraviolet radiation far stronger than what Earth receives. This extreme radiation can strip away vital atmospheric elements, including hydrogen, nitrogen, and oxygen. Even if Proxima B lies at the right distance from its star, that alone doesn't guarantee habitability. Atmospheric stability is key for life. It regulates temperature, shields against harmful radiation, and retains surface water. Without it, any life on the planet would be exposed to the full brutality of space weather. In short, Proxima B may look Earth-like at a glance, but in reality, it may be far from livable. So, while the discoveries are thrilling, scientists remain cautious. Proxima B is a fascinating world, but for now, its ability to host life remains uncertain. The quest to uncover the truth about Proxima B is far from over, and hope remains high among astronomers. One of the most promising tools in this mission is the James Webb Space Telescope. After years of anticipation, it finally launched in 2018 and is poised to play a critical role in determining whether life might exist on this nearby exoplanet. But, as is often the case in science, things are rarely straightforward. The telescope required several fine-tuned adjustments to ensure the accuracy of its images. According to Abby Tabor, a theoretical physicist at Harvard, if a planet like Proxima B absorbs light from its star, it can also emit in the form of infrared radiation. The James Webb Telescope was specifically engineered to detect this infrared light. It can capture such emissions from a planet's surface and search for signatures like water or atmospheric patterns that could hint at life. However, not all atmospheres support life. Ed Turner, an astrophysicist at Princeton, points out just because a planet has an atmosphere doesn't mean it's habitable. It could be more like Venus, blanketed in thick, toxic clouds with extreme temperatures, making life impossible. The journey to understanding Proxima B is filled with hurdles. Despite the promise of the James Webb Telescope, other challenges loom: budget constraints, technological barriers, and observational limitations. Still, the stakes are enormous. The potential to explore a nearby Earth-like planet and possibly uncover signs of life is a dream that continues to drive space exploration. What makes Proxima B especially captivating is its proximity. It's the closest known exoplanet to Earth. This alone makes it an ideal candidate for future interstellar missions. Even more exciting is the fact that it's roughly the same size as Earth and orbits within its star's habitable zone, raising the possibility that it could support life. While reaching Proxima B remains a daunting task, current spacecraft like Voyager 2 would take about 75,000 years to get there. New technologies offer hope. One proposed solution is the use of solar sails, ultra-thin reflective sheets propelled by solar radiation. These could potentially accelerate a spacecraft to a fraction of the speed of light, enabling missions to the Alpha Centauri system, and Proxima B along with it. This cutting-edge technology may not only make interstellar travel feasible, but it could also provide critical data about the habitability of other worlds. That said, the presence of an atmosphere still doesn't confirm life. If Proxima B has a thick, Venus-like atmosphere, it could be uninhabitable despite being in the right zone. Here's an intriguing detail. The James Webb Telescope is sensitive enough to detect infrared emissions from Proxima B if they reach just 5% of the planet's daytime brightness. That may sound minor, but for a star dimmer than our Sun, it's a significant threshold. Speculatively, if an advanced civilization exists on Proxima B, they might use orbital mirrors to reflect light from the sunlit side to the dark side, an idea that excites researchers. Across the galaxy, thousands of exoplanets await discovery. These planets vary dramatically. Some are enormous gas giants, even larger than Jupiter, dubbed super-Jupiters. Others, like hot Jupiters, orbit perilously close to their stars, enduring temperatures hot enough to melt metal. Their turbulent atmospheres and searing climates paint a vivid picture of the diverse and often hostile environments beyond our solar system. Neptunian exoplanets, though similar in size to Uranus and Neptune, are a fascinating category of distant worlds. Within this group are hot Neptunes and mini-Neptunes, which are generally smaller and orbit much closer to their host stars than their larger gas giant counterparts. These planets remain shrouded in mystery, particularly because their atmospheres are difficult to study from such vast distances. Then there are the Earth-like exoplanets, resembling our own planet in many ways. These range in size from smaller than Earth to nearly twice its diameter. Super-Earths, a particularly intriguing type, are more massive than Earth but lighter than Neptune. One of the most captivating among these is Proxima Centauri B, which orbits the red dwarf star Proxima Centauri. It's classified as a super-Earth, with an estimated mass about 7 times that of Earth. While it orbits relatively close to its star, it still lies outside the habitable zone, making the potential for life uncertain. Interestingly, Proxima Centauri B isn't alone. It has a companion, Proxima Centauri C, discovered in 2020 using pre-recovery data from the Hubble Space Telescope. This planet has a much longer orbital period, circling the star once every 5 Earth years. Even more compelling is the possibility that it may be unusually bright, potentially due to the presence of a ring system. The Proxima Centauri system may hide even more secrets. In 2019, astronomers detected subtle shifts in the star's motion that could indicate the presence of a third planet, Proxima Centauri D, a planet roughly the size of Mercury or Mars. If confirmed, It would add another fascinating chapter to the story of our nearest stellar neighbor. Imagine looking up at the night sky and knowing it's not just stars that fill the cosmos, but a staggering number of planets, each with its own unique traits and orbit. The universe is full of surprises, and exoplanets are among the most thrilling of them all. Thanks to rapid advancements in technology, it's an incredibly exciting era for space science. Although the exact number of exoplanets remains unknown, we're certain they're out there, just as sure as we are about the stars themselves. Studying these distant worlds is no small feat often. They're hidden by the blinding glare of their host stars. But with modern tools, direct imaging has become possible. For this to work, an exoplanet must be large enough to detect, far enough from its star to be distinguished, and young enough to emit detectable heat in the infrared spectrum. While these conditions are rare, when met, they give us a fascinating window into the planet's characteristics and composition. Most exoplanets, however, are found using indirect methods. One key technique is radial velocity, which detects the subtle wobble a planet causes in its host star. Another widely used method is the transit technique, famously employed by the Kepler Space Telescope. This approach tracks the slight dimming of a star's light as a planet passes in front of it, revealing information such as a planet's size, orbital distance, and temperature. Here are a couple fun facts. Over 22% of Sun-like stars are believed to host Earth-sized planets in their habitable zones. And the TRAPPIST, one system is home to 7 rocky exoplanets, some with evidence suggesting the presence of water. Just like our own solar system's planets have moons, many exoplanets might also host exomoons, though detecting them remains a challenge. So far, we discovered over 4,000 exoplanets, and that number is growing steadily. Among them, hot Jupiters, massive gas giants with short orbits, are the easiest to detect. But there are countless more waiting to be found. NASA's James Webb Space Telescope, JWST, is playing a crucial role in this cosmic exploration. This powerful instrument has been capturing unprecedented images and collecting invaluable data about the universe in infrared wavelengths. One of its most groundbreaking findings so far is the first confirmed detection of carbon dioxide in the atmosphere of an exoplanet. This gas giant, located 700 light-years from Earth, orbits a sun-like star and offers vital clues about planetary formation and atmospheric composition. NASA Administrator Bill Nelson called this discovery a new perspective on the universe we've never seen before, igniting excitement among scientists and astronomers around the world. And the discoveries don't stop there. JWST has also been observing IRAS 110, a young, glowing object illuminating surrounding clouds of cold gas. The telescope's infrared vision revealed distant stars hiding behind these icy clouds, part of its broader Ice Age project, which studies the formation of ice and its role in shaping icy bodies like comets. Moreover, the telescope recently captured the inner workings of a dusty disk surrounding a nearby red dwarf star, seen for the first time at these light frequencies. It's a glimpse into the early stages of planetary formation and just another step in unraveling the mysteries of the cosmos.